Okay. So, like I said, the asymptote is an imaginary line that a function approaches but never touches. So, like for this example, the asymptote, the horizontal asymptote here is y equals 0. Okay. That is the equation for this line. Okay. Do you remember Hoy bucks? If it's a horizontal line, it's going to have a 0 slope, and it's going to be in the form y equals. Well, y equals 0 is that x-axis. Okay. Domain and range work the same. So for this example, the domain is talking about what are all of the potential x values. And because the arrows are there, this graph goes forever to the left and forever to the right. So the domain would be all real numbers or negative infinity to positive infinity. This example is not in your notes. It's just kind of a preview example, and then we're going to go straight into your notes. Okay, the range. What does range represent? Do you remember? If domain is x values, what's range? Y values. So what are all of the potential y values? Well, they start at 0 and go up, right? Those are your potential y values. So the range is 0 to infinity. Because that graph approaches that line y equals 0 and never touches it, you cannot include the number 0. That's why I use the parentheses, not bracket. Okay. Can you see the y-intercept here? Where does that blue graph cross the y-axis? Zero, 1. Okay? So the y-intercept is 0, 1. Does this graph cross the x-axis? No. So you would put in A or none. Okay. The asymptote, we already established that was y equals 0. The end behavior. Okay, as x increases, we are looking to the right, like the right side of the graph. The right side of the graph, is it pointing up or down? Up. Okay, so as x increases, f of x, or y, is also increasing, or increases. Or you could say it's approaching positive infinity. Because you're going to see both of those. Y'all okay? Okay. As x decreases, as we look at the left side of that graph, what's going on? So as we look to the left, as we look at the x-axis on the left, what is the y doing? Where is this pointing? Where is this approaching? It's getting really close to that y value of 0, right? It doesn't go beyond here. It stops. It's like a brick wall. It stops here. So the y's, it's approaching 0. Okay, that's just an example of what we have to do. Now look at your notes. Look at number 1. we have this function. It says f of x equals 1/4 to the x power. So what I'd like you to do, get your calculator. And I want you to make this graph. Get your points. So get your calculator, go to the table function, and type in 1/4 to the x power. Okay, it looks like some points start around the number 1. -1, sorry. So when you look at your table, when x is -1, what is y? So when x is -1, what's y? 4. So we've got the point -1, 4, -1, 4. What's next? 0, 1. What's another point? 1 and 1/4? Yeah. And then I got 2 and 1/16. That's just really close to 2. So we have 4 points. We can make a curve with this. I'm going to do my best. Okay, so that's your graph. Why?
The lines on it.
Guesstimate. Do your best. Not enough. Okay. So the asymptote, the horizontal line that this graph approaches is y equals 0. Is there an x-intercept? No. So this would be no or NA. What's the y-intercept? 0, 1, right? What's the domain? Does it go left and right forever? Yeah. So the domain would be -infinity to infinity. The range starts at 0, then it goes to infinity. Okay. Hold on. If you think about the end behavior here, it reads, as x increases, So as we're moving this way on the x-axis, what is the graph doing? What is it approaching? What is the y doing? It's approaching what? 0. Okay, if we look at the right side of the graph, it's approaching 0. We're going to put approaches. As x is decreasing, as you're moving from right to left on this graph, if we look at the left side of the graph, is it pointing? How is it pointing? Up. Okay, if we look at the left side, pointing up, it's approaching infinity, or it's increasing. Okay, so let's do another one. Let's zoom in. Okay, number 8 says f of x equals negative 2 to the x power. So go ahead and get your points. Start your table at negative 2. Somebody help me out. What are the points here? Negative 2. When x is negative 2, what's y? Negative 1/4. When x is negative 1, what's y? When x is 0, what's y? Huh? And when x is 1, y is negative 2. When x is 2, negative 1, 4. Okay, so those are our points. We have negative 2, negative 1/4, negative 1, negative 1/2, 0, negative 1, 1, negative 2, and then 2, negative 4. So do your best, make your curve. Okay, the asymptote here is still y equals 0. Okay. Because it doesn't go above that, right? Does it cross the x-axis? Does that blue graph cross the x-axis? No. So this would be no or NA. What is the y-intercept? 0, -1. Domain would be all real numbers. So negative infinity to positive infinity. The range. Those are the y values. So the range starts all the way down here. Wrong pen. Hold on. The range starts at negative infinity and it approaches 0. It goes to 0. So we have negative infinity to 0. When you're determining domain, it's left to right. When you're determining range, it's bottom to top. In behavior, as x increases, as we look at the right side of that graph, the right side's pointing down. So that would be approaches negative infinity or decreases. Okay. As x approaches negative infinity, if we look at the left side, that's approaching 0. Okay, one more question. It's at the bottom of the page. Okay, number 15. In the function y equals 275 times 1.4 to the t power, the variable y models the number of cell phone subscribers in the small town of China Grove in 1985. The variable t represents the number of years after 1985. How many cell phone subscribers were there in 1994? Okay, so t represents years. So t is typically going to represent some amount of time. In this case, it's years. So we're looking at from 1985 to 1994. How many years is that? From 1985 to 1994. How many years is that? 9. Okay, so our t is 9. So when you have this equation, y equals 275 times 1.4 to the t power, we're going to put in a 9 for t. And then you simply plug that into your calculator. You don't need to use the table function for this. So someone tell me what you get. And round to the nearest whole number, because you can't have half of a subscriber. 5,686. Okay. So on the back of this page, you have one more graph you have to do, just like what we did on the first 2 examples. And then you have 17, 18, and 19, you have tables, and you have to write the equation from the table, kind of like what we did Tuesday and yesterday. On 20, 21, and 22, you're given a graph. And if you can't see the point, I can help you. Let's see. Okay, yours showed up very clear on these. You can see those points, right? Okay. So on 20, 21, and 22, you're getting a table from your graph, and then you're making an equation based off your table. Again, same thing we did Tuesday and yesterday in Delta Math. And then number 23 is kind of like this last question that we just did. Okay? And that's your homework. Your homework is to finish the rest of these notes. Tomorrow I want to take a very small, short, open note quiz to see where you're at. Open note. So make sure you have your notes tomorrow. If you need to take extra notes tonight, do that. If you need to print some stuff tonight, go for it.